Alright, as I was reviewing the last video, I noticed I was struggling a lot with this obtuse platform idea. So I'm going to cover that again to see if I can make it a little bit better this time. This kind of thing is important for beginners, and I know that this might be repetitive, but for beginners, you know, you might be, or they might hang on a certain word or a certain sentence or a certain idea about flint knapping and the explanation of it, and try over and over and over and over to get that to work, and it doesn't work because maybe they've missed something or I said something wrong. So I'm going to try this again, and I'm going to try to explain why some of these platforms actually work as opposed to other platforms, and what happens during the application of pressure on these platforms or on these edges. I think I stated in one of the videos that it doesn't matter. Platforms can be anywhere that the tool is applied. Okay, and you either create a platform, an area where you apply the tool to apply pressure, or you look for one that's naturally occurring. Okay, so a platform is not specifically man-made. You can look for one or create one, either way. And there's acute and obtuse type edges, platforms and such. And I'm going to try to explain the obtuse one a little bit better, but I'm going to go over both. Alright, so first off, a lot of beginners crush their platforms. Okay, whether this type or that type. They get crushing going on right on the edge as they're applying pressure or force or whatever, and nothing happens. It just crushes. Or it crushes before the actual main force drives a flake, so you get a short flake, or you get some weird stuff going on. So and that happens especially with thin pieces, thin work pieces. Now, the easiest way for me to do this is to blow it up. A natural edge without abrading is going to be, it's going to be all over the place. When you zoom in on it, zoom in on the edge, after striking some flakes off, you could end up with a really irregular edge if you look at it closely. Okay, and some of these are steps and so forth. Let me just extend these out. Try for kind of a isometric view of this thing here. This might be a step fracture in here, and the contour. This is like a slice through the workpiece. I'm slicing through here. If you know what I mean. Okay. Now, what abrading does is it knocks off the upper surfaces so you don't have the sharp stuff sticking out. Okay, but you still have irregularities on the edge. Okay, and abrading will bring back this edge here. Okay. Now what that does is it allows the tool to sit more firmly to drive these flakes. Because if you have a sharp piece sticking out, obviously it'll be harder to control exactly where this flake's going to come off. It'll have to come off up higher to avoid this, this very weak spot here. You can't drive off of this weak spot very far. You press on that, it's just going to snap this off. This little area, it's just going to snap it off. So what you do is you dull it, bring it back so that this tool can actually apply a lot of force. Okay. So when you're actually pushing on it, it'll allow you to apply a lot more force before this thing detaches so that you can get a long flake. Okay, and you want to try to clear all these irregularities. Now in this case, this edge is technically one of these obtuse edges because you're rounded it off. But you have these irregularities in there, it'll probably snap right on one of these irregularities. Let's just say there was a little bump in there, whatever, a little crack or whatever. It'll initiate there and then take off. And the more pressure you have to begin with, the longer the potential flake. However, if you have this situation where you've got concavities on the underside, if you look, the flakes will like to take the path of least resistance. This shock wave to create the flake. The flake and the shock wave will take the path of least resistance. So there's a possibility that it could actually snap right here at this concavity, but most likely it'll snap here at this concavity. Okay, and you just get a short flake. So what you need to do is make sure that you've got more of a concavity like on this side, a convexity like this side here. Okay, so in this case, if you flip it over, it'd be more advantageous to take a flake off of this side. And you can abrade this more too if you want. Okay, to try to get this down to where these irregularities are smoothened out more. You're still going to get some. Okay, but as long as these irregularities are not too drastic, and then you'll have to take some of this off here by striking, creating a better platform. So this tool will be able to build up pressure or build up force before the detachment of the flake. Okay? You have a much better success if the underside or the dorsal side of the flake is convex. Okay? So you may have an issue with the snapping of it right here at this narrowness here, but it's unlikely because this ball of percussion is going to probably go past it to create a thick enough area to be strong. And down here you might have an issue here. It might cause a step right there. But usually steps are caused much further down as it gets thinner. Like right here, you could have a step here. But usually it'll feather out if you have a concavity just at the end of the flake. It'll feather out and it'll take a not so difficult path and just snap or exit here. Okay. Now, in some cases, as you gain more experience, you can kind of figure out what's going to happen as you're applying pressure, and you'll feel part of the edge crush as you're applying pressure, but you keep applying pressure. And if you do it just right, like I've seen a lot of guys with their pressure flakers, they put them way up here like this. So as they're applying pressure, these sharp edges will start snapping off. Sorry, You know, that'll snap off at first, but they keep pushing more pressure. This will snap off. You know, you'll have what I call pre-crushing going on before, you know, you get some crushing before, but right here is a critical point right there. They're actually pushing on this part here. You know, these will snap away at first, and they'll be pushing on this part right there, and that'll be the the initial point of the flake removal. Okay, so instead of dulling it like this, instead of dulling it to get this shape, they just apply pressure ahead of, with the tool way ahead of the edge, and it'll snap off some of these weak areas before it gets to a thick area where the tool is actually putting pressure at that critical point to remove a flake. See, a lot of guys make the mistake of putting pressure at that critical point on the very edge, and all they're getting is a bunch of crushing, and they're just crushing all these pieces off here, and they're left with an edge like this, and they got all these pieces that are crushed off. They just take off the edge, no flake, just crush off the edge. Experienced knappers will either dull it down to get this look, or they'll anticipate the pre-crushing and let all that stuff crush away before it gets to where they really want to make contact, and then push off the flake. But it's all one motion. This pre-crushing and stuff goes on in one motion with the final flake removal. Okay. Now, I don't usually do it that way. This is I call it pre-crushing, but I don't typically use that method. Okay, but it can be used. I like to dull and strike off the delicate parts of the edge beforehand. Okay, so to strike off the edge, if you're striking directly straight, you get the Hertzian initiation. Okay, and a lot of times the angle I like to have a range of, I think it was 65 to 85 degrees. When you strike off a Hertzian cone, this angle is more like 50. Okay, let's assume that this that 0 right here. Okay. That's 130. That's 50. So if you strike straight down like this, you're not going to get a very good or very strong platform right away. I mean, you can if you use this pre-crushing method, but if not, you'll have to either strike it in a different direction or dull it after you strike it. Okay? I tend to strike it multiple times, and I come in from this direction here. Okay, so this angle is not 50. It ends up, I mean, it is 50 here. I guess I shouldn't have put this as 0. It is 50 there, but if you change this angle to apply force this way, strike off this way, it brings the platform edge or platform surface more in line with what I like on this. Okay, and some people beginners will have trouble understanding how to strike the edge to create good platforms. So this is one thing to keep in mind. Okay, now before I run out of time, let's get back to this obtuse edge and how to remove flakes from here. I'm going to blow this up. Okay. You can remove flakes off of this very tip easily by striking, like, or dragging an object, or even striking just the very tip. Okay, because there's not much mass there, and you can, you know, knock out a chunk, you know, concave area just by brushing it. You know, just either taking a hammerstone or whatever. Let's see. Something that looks like a hammerstone. Take a hammerstone and go this way with it. On this obtuse edge, you can sometimes remove a little flake by hitting it like this. And then from there, from this acute area, you can push off a flake easily, or more easily. Okay, but and this is where I struggle, because there's so many different ways to approach this, and this is about 30% of flit knapping, I would say, is obtuse platform angles. In all of flit knapping, it's about 30%. You're dealing with this kind of situation where it's not a sharp edge. It's like this. Okay, and you've got to either create a sharp edge or work with what you got. Okay, the other 70% is the acute edges. Okay, now, like I said, you can brush this and take off small chunks and small flakes, or hitting. This doesn't necessarily have to be brushing. You can also strike at a very glancing type of angle and remove these flakes to create these areas where you can get in to initiate. But you can also initiate, especially when you're working with cores, like conical cores. And you've seen them where flakes are removed from these cores, all right? And you've got, in many cases, an obtuse situation where you're using a vertical punch. Okay, and setting it on the edge. Now you can abrade the edge, the surface here. You can also strike the top of this and then detach the whole top and create the acute angle, the acute edge this way by removing the top. Okay, you can do it that way. So there's two ways of dealing with this type of core. You can either work with the obtuse situation, or you can remove this cap. I forget what this is a special name for these caps, so to speak, when they're removed. You can see these in some debitage piles, and I forget what they're called, but anyway, this is one part of flit knapping where you'll see this dealing with the obtuse angle. of the platform. Okay. The other one, of course, is with reduction of nodules. And you'll see me hitting edges. Let's see. You'll see me hitting obtuse edges sometimes. Like there's one here. Okay, let's see if I can get it to focus. This is obtuse here, but I can still remove flakes because there's a little bit of a concavity. So I can strike down this way. But usually what I try to do is strike at this angle here and remove short flakes. It's much more difficult to remove long flakes from an obtuse platform angle. So that's why most of them are removed from the acute. And this is pretty typical here, this angle here. And I don't know if you guys can stop the video and measure that, but that's probably like 85 degrees right there, which is pretty good for just about any type of tool. So I would strike that for sure after dulling it a little bit. And again, you dull it so that for two reasons. One, you can actually know where the best edge is for, so you know how high up to go. And also so you don't get all this pre-crushing. Some people like it, some people don't. I tend to not like crushing going on before the actual strike, or during the actual strike. I prefer to dull it down. Okay. So with these, I tend to strike glancing blows to get some sort of dished out area. Or you can abrade these surfaces to create more friction. Sometimes you'll see especially on cores, where you'll see scratches on archaeological specimens. You'll see scratches on the surface for the vertical punch. And those scratches, there's a debate on what exactly they do. Some people say it actually creates a situation where the cracks will initiate somewhere in one of those scratches, and other people say it's for the gripping of the tool, and some people say it's for both. The tool grips better and also causes some initiation, or helps to accelerate the initiation of the flake. But I think it's mainly for it's mainly to cause irregularities to help with the flaking, to help initiate. Because sometimes you'll find that these striations or these scratches are in this direction primarily, and they're still striking flakes off. So it doesn't add any it seems counterintuitive, but you see some scratches going this way, and what I think it is just a way to create irregularities in the surface to help initiate the cracking. But who knows? All right. I just went off on a tangent there. Anyway, that's what I mean by abrading. You're scratching the surface. It's not necessarily making it smoother. It's actually making it rougher. That's what I was trying to get at. Okay. Because most abrading, like I showed here, will make the surface smoother and not rougher. the type of abrading I'm talking about for the obtuse edges are roughening abrasions and not smoothing abrasions, if that makes sense. Okay. So, again, to make long flakes, you're going to need to apply, as a general rule, lots of force for long flakes. Okay. And if you have a really delicate edge, you'll get a lot of crushing going on before you're actually going to be able to apply enough force to drive that long flake. So this has to be strong. And you achieve strength either through shaping like this with strikes, with abrading to round it, or creating. You can create strength by creating an obtuse edge. Okay, or this method here where even if it's weak to start with, you're putting the tool high enough up on that edge so any crushing going on before, it doesn't matter too much, because the tool is going to rest up here. This point here is going to rest up there for the important flake removal. Okay, and all this is going to get crushed away. So there's different methods for getting this to be strong. All right. So I just wanted to go over that before I go on to the next subject. Okay, hope that helps.